Okay. Talk about databases, as the slide tells me. I was answering questions just now. I was completely tripped up. I thought I did two 116s. I thought this was another 116, so my mind's got to get used to this. This is 312 now. So let's talk about databases. Finally, not doing the same thing after 3 times in a row. So databases, this is when at this point, we're on application objective 2 and 3 on the homework. This is talking about the API stuff and the setup of what we'll eventually talk about in this lecture, Docker Compose, you'll need for all of your objectives. So you do have to set up with Docker Compose when we get to that part. The database stuff is application objective 2 and 3. That's when this will become pertinent. So learning objective 1, learning objective 2, application objective 1, all of that, I'm done talking about all that content. Obviously, I'll entertain questions and stuff, but there's no more lecture content about those. You're good for the first 3 objectives of the homework assignment, 1. You can get all of that done just without the Docker Compose setup until the end of today's lecture. At the end of today's lecture, you should be able to make a submission that would have credit for all 3 of those objectives. And then we won't get to the complete application objectives 2 and 3 until next Wednesday. So there's a bit to wait on that one if you're eager to get going on that. So databases, I'm going to rush through databases pretty quick. I'll give a nice overview and everything, but I'm not going to talk too much in detail about them, partly because I assume that if you made it this far, you've experienced databases before. It may or may not be true, but if it's not true, I'll give the brief overview. If it is true, don't worry, it will be brief. I'm not going to belabor the point too much. But database is software that's going to help us store data to disks. In just general, high-level explanation, that's what our database does. It does the same thing as if we wanted to do file I/O. If we just wanted to save all of our data as CSV files and JSON files, we could do that. But a database is going to do that for us, help maintain all that file I/O, all that storage, and it's going to have tons of optimization. It's going to work so much better than just storing your own files and reading your own files. For one, it can index things, which gives us much faster lookup speeds and everything. Just very efficient. It's the way we store data in computer science. It's just how we do it when we write our software. So we don't have to think about all the low-level functionality, how we're going to format our data or anything. The database is going to do it for us. So we're going to look at 2 different types of databases. We're going to look at MySQL and MongoDB. And these are 2 kind of different approaches to databases that are going to help us store data. For your homework, you can choose one of these 2, but I'm going to introduce both. You're going to see both of them in your career quite extensively, either these 2 or versions of these 2. Yeah. Oh. Was it left in this lecture, in this hall? Ooh. I mean, I can. Do you want me to take it and leave it down here, or do you want to try to track them down? Somebody's going to be looking for it. Thank you.
Yeah, you're welcome. Thank you.
I don't know their passcode. I tried. On the lock screen, it should have, I guess maybe it shouldn't, but some identifying information. How do we tell people that they lost their phone? So MySQL, let's start with this one. So MySQL and MongoDB, actually, it's going to be software that runs on your machine. And it's going to run on your machine and listen for TCP connections, just like our web servers, except they're not going to speak HTTP. They're going to speak their own protocols. SQL, MySQL, MongoDB, they're going to use their own protocols. MySQL, when you download and install and run the server, it's going to be software running on your machine, listening for connections by default on port 3306. So you'll connect to it on port 3306, create a TCP connection, create a TCP connection, and then you can send it SQL statements and SQL queries to be able to store and retrieve your data from the database. So what do I have on this? Oh my goodness, my brain. Nothing. I don't want to talk about any of that. So when you connect to your database, you'll write software that's going to make that connection, but you're not going to have to handle the low-level details. You'll install a library, which is going to be your database client, and then you're going to use that client library to be able to actually make your connections, to send the statements and send the queries. So for this, I'm using the JDBC MySQL library. This happens to be Scala code because I was doing this in Scala when I made these slides. But the concepts are going to apply to any language. We're going to connect to the database through a URL. And we're going to give the username and password, which are going to be something you set up when you install MySQL. So you download and install MySQL. During the installation process, it'll say, what do you want your username and password to be? Or rather, what do you want your root password to be? The password for your root account. You can set up an account. You can use root. However you want to set it up, make sure you're consistent between what you set up and when you connect to it. If you don't have the right username and password, of course, you're not getting in. Yeah? It's when you try to access it. Yeah. So you want to set up the username and password, or else somebody can remote access in. It's just listening on a TCP port, so it can be accessible over the internet. So somebody knows your IP address, checks 3306, knows your username and password, they can get into your database. So you want to make sure that username and password are secure. When we talk about, since we're on the topic, MongoDB, when we get there, by default, it closes off outside connections. So we're not even going to set up a username and password, but you still can if you want to accept outside connections in MongoDB. Then you create a connection, and then you use that connection to talk to your database. Actually, I do want to say one more thing about that, because I think I removed the slides, but I shouldn't have. When you have your password like that, don't do what I did on the previous slide ever. This is terrible. Don't hard code passwords into your code ever. This is a very, very bad thing. Never, ever, ever do this. Whoever has access to your code at that point has access to your passwords and then can access whatever you are controlling with that password. Don't do that. The standard solution to this is to have use environment variables, or I should say a standard. There's a lot of ways to do this. So use environment variables. Here you would just read your environment variable from your operating system, and then when you go to deploy your app, you would set those environment variables at the OS level. Would be pretty much the standard way to do that. Or you have your passwords in a config file, and in that config file in your repo, you just have a bunch of placeholders that aren't the actual passwords. And then when you go to deploy, you'll set those passwords, change those passwords in that config file. Don't put them in your code, especially if you're connecting to like 5 different services. You don't want to go to all those 5 different places in your code and update that code when you want to change your password. It's bad practice, very bad practice to do that. Have them either all in one config file or set the environment variables. So once we're connected, we can start sending SQL statements to the server. So here, I want to create a table. Whenever you use SQL, you have to create a table first, which is going to be kind of like a CSV file. You're going to define the columns of data, and then you can add rows of data to that. So I'm creating a table named players with 2 columns, one for username and one for points. And I'm going to create the table if it doesn't exist. This is important if you are going to use SQL or MySQL this semester. Create the table if it doesn't exist, or any other way that you can get around this problem. But the problem is that if you try to create a table that already exists, you get an error and your program crashes if you don't catch the exception. So if you do create if not, if it doesn't exist, then you only create it as it implies if it doesn't exist. And if it already exists, this just doesn't do anything. So if you're creating your tables on startup, check if they exist, and then only create them if they don't exist. So just a word of caution if you're using SQL. And then when we want to insert values into our database, we're going to use prepared statements for that. So we're going to create a statement like this, which says, I want to insert a row into the players table, and I'm going to have 2 question marks as placeholders. And in this specific library, this is easier in Python and JavaScript because they're not strongly typed languages. This being Scala code, being strongly typed, I have a bit more work to do. I'm going to put my placeholders here and then replace those placeholders one at a time with indices starting at 1. Boo. The indices start at 1 with MySQL. So 1 is the first question mark. I want to replace that with a string, Mario. And the second question mark is question mark 2. And I want to replace that with the int 10. In Python, you'll slap a comma right here and then just give a list of all your values, matching the order of the question marks. It's a lot simpler. But strongly typed, we can't do that. We can't just have a list with mixed types, so we got to do it a different way. And then execute to finally fire off that statement. No matter what language you use, if you see these question marks, if you're writing these question marks in your code, you're on the right track. If you're using string concatenation, you're not on the right track. Do not do that. So the alternative here, you could create a SQL statement by just using string concatenation here. You could just concatenate whatever value you have into your statement here, just using plus and then another string plus, and create your statements that way. The danger with that, and something we'll be watching for during grading if you're using MySQL, is that you can be susceptible to SQL injection attacks, which I think probably by this point most of you have at least heard of, if not all. SQL injection attacks, this is where they come from. If you're using string concatenation, and specifically when you're creating your SQL statements by concatenating strings containing values that were provided by your users, who should never be trusted. Have I said that yet this semester? Never trust your users. You should never trust your users. If you're having user inputted data and just string concatenating into your statements, you're basically begging for a SQL injection attack. So you would expect inserting into the players table that somebody's going to type their username or their player name or their actual name, something that makes sense, right? Well, what if for their name they choose this? They just start writing SQL code as their username. Well, if you're just using string concatenation, your MySQL client library might just interpret this as SQL that it should run. And all of a sudden, all your data's gone because they just dropped your table. They just deleted your players table, and you lose all your data. They might do something much more malicious than this. If somebody's actually executing a SQL injection attack, one thing that they could do is edit their own profile, write some SQL code to edit their own profile in the table, in like a user's table, and give themselves admin privileges so they can access everything on your site. And eventually they might even be able to access your server in general outside of the database and then just have full control over everything at that point. At the very least, they're going to send like a select star to your database and steal everyone's data. That's the very first thing we should worry about. And then they can do even more malicious stuff after that. Although stealing all your data is pretty bad already. Very, very bad. And this is the most common successful attack on servers. Be careful. If you have these prepared statements with the question marks and then inserting the data, this is only going to treat whatever's here, even if it's given by a user, it's going to treat it as a string literal, not as part of the SQL statement itself. So always, always use your prepared statements when using SQL. Always. That can't be stressed enough. Hopefully this isn't even the first time you've heard that. Hopefully you've heard that in at least one other class. You'll hear it from Alan in 365 for sure. You might have heard it in 199. You probably heard it in 115. I believe you took it at the time we were still covering that. That's removed from 115 these days. You might have heard it 4 times by now, at least. If any of you do that in the real world, I'm going to come find you. And like, how many times do we have to say it? Always use prepared statements. And then when you want to get your data, you're going to use a select statement. This select star from players is going to give me everything from the players table. And then we're going to loop over the results and gather the results in whatever format we want. This is going to depend on your language, but this is the typical setup. You're going to fire off the query. You're going to get some results object, and then you're going to iterate over the actual results and do whatever you got to do with those results. So SQL is a row-column structure. The S in SQL stands for structured. It's a very structured database. It's a very structured format. And it's very similar to a CSV. In 115, we talk about CSV parsing. SQL is very similar. Obviously, it has many differences, and it's much more sophisticated and cooler than CSV. But deep down, it's like CSV, or it's like a spreadsheet. It's rows and columns. So what if we want to do something a bit trickier? What if we want to store key value pairs or an array, some data structure? So I have a table called students. It has your name and person number, your UBIT, and it has your scores for all the homeworks. How do I store those scores in a single column when it might be a different number of scores? I'm worrying that that's a bad example because it would be the same for all of you. But what if I want a column that keeps track of your recovery opportunities used, and it has a string for each thing that you've used a recovery opportunity on? How do I jam that into one single column in SQL? And the short answer is you kind of can't. The longer answer is, well, you could store a JSON string, but at that point you're just using JSON. But you kind of can't. And you got to use something called joins. You would create a separate table for recovery opportunities, and then use joins and foreign keys and all that stuff. Maybe you've used in a different class, depending on what courses you took, or you used on one of your own projects. But you would use joins with separate tables and store all your data in separate tables. Or you give MongoDB a try. MongoDB is going to solve that in a much simpler way. Which version of MySQL? I'm not prepared to answer that question. I thought it was just MySQL community, but in the community download section. I don't know, the latest one, maybe. But clustered CGE doesn't sound like what you want, though, just based on the name. That sounds like it's going to be distributed. But I don't know off the top of my head. Oh, yeah, and that one nerd, nice name, has you covered on that. Just whatever you want to use, whatever works for you. I want to see this. Or try MongoDB. So MongoDB is another option. And by the way, you don't even have to use one of these two databases. You can use whatever one you want. These are just the two I want to highlight. It's one SQL database and one non-SQL database. And they're two of the most popular databases out there being used. So I just want to highlight the two different flavors of databases that are out there. So MongoDB is similar to MySQL in that it will run its software that you download, install, run on your machine, and it'll listen for TCP connections on 27017 by default. There's no reason to change these defaults, by the way. Just use the default port numbers. They're standard. The only reason you would ever change the default port, in my opinion, is if you're running two databases, if you're on two instances of MongoDB on the same at the same host, which at that point I'd say, why the hell are you doing that? But that'd be the only reason I could see why you would want to change that port number. MongoDB pretty much claimed 27017. Nobody else should be using that. MySQL claimed 3306. Just don't use those ports for anything else. Those are reserved for these purposes. So MongoDB is a document-based database, meaning it effectively, you take JSON objects and just stuff them into the database. and then it just stores your JSON objects, which it refers to in its documentation as documents. So this is just like your dictionaries in Python, your objects in JavaScript, and if you're using one of those two languages, which most students in this class use one of those two, most of you will use Python, you just take your Python dictionaries and you say, hey MongoDB, store this for me. And that's it. It's stored. You don't have to create a table. You don't have to worry about your prepared statements. You just say, here, store this for me. And that's it. So once you have MongoDB running, same thing. You're going to download a client library. And when I say download a client library, I got to take a time out to talk about this, actually. When I say download the client library, that's going to be in your requirements.txt, ideally, in Python. And when you download your dependencies, you have to get that in there somehow. So either in a requirements.txt, like I had my setup last time for my Docker file, or pip install and just install it directly through pip in your Docker file again. Make sure that gets in your Docker file to install your dependencies. But you'll find the MongoDB dependency, install it. Those are both Python examples. Package.json if you're using Node, or npm install if you're using Node would be the parallels for that. But make sure you have it installed into your, downloaded into your project with your project code. So MongoDB, when you have it installed and you're connecting to it, it works with databases and collections. This is similar to the database and tables in MySQL. So you'll connect to the server. You'll access a database in the server. A server can have multiple databases. Same with MySQL. I forgot to mention that. And then in that database, you'll have multiple collections, which are similar to your tables. That's a grouping of data, I suppose, would be the way to say it. And that's where you're actually storing your information. So we're going to connect to Mongo, giving the host name, and there are optional parameters here. I'm using the defaults for the rest, like the default port. I'm going to run it on 27017. That gives me my connection to the server, including the TCP connection. I'm going to access a database from that, and this is Python code if you can't see that. I'm going to access the database that I want to connect to, and I'm just going to call my database whatever I want. And then I'm going to connect to a specific collection in that database. I'm going to call the collection whatever I want, and then the collection is how we're going to access and store data. MongoDB has us covered in a lot of aspects here. If this database doesn't exist on the server, and I ask for a database that doesn't exist, you know what MongoDB does for us? It just creates it for us. When I access a collection that doesn't exist in a database, it just creates it for us. So if it already exists, it'll give us what exists. If it doesn't exist, it creates it for us. So I'm just accessing this, whether it's the first time I access this database and collection or the billionth time, it's the same code. I don't have to worry about if this table doesn't exist. Don't recreate it. I don't have to worry about that stuff. MongoDB just says, I got you. I know what you mean. MySQL, not so much. MySQL is a bit more strict on that. And with our collection, if we want to insert data, we just throw, in this case, a Python dictionary in there. And that dictionary is going to be stored in the collection as a BSON object. So we're just going to throw our document in there, in this case a dictionary, and it stores it for us. No such thing as a Mongo injection attack. MongoDB doesn't have injection attacks. When I'm storing this data, I'm not giving it a string. When I'm storing data with SQL, I just give it a string, and then the server parses that string and executes it as SQL code. SQL is a programming language. It runs that code. It interprets that code. MongoDB, not so much. We're calling the insert method and giving it data that is not a giant string. This is not a JSON string. This is a Python dictionary. And then the library, the client, is going to convert that into I'm not 100% sure what it does. But it's eventually going to be a BSON object. I'm not sure if it's the client-side code or the server itself, which will convert it to BSON. I don't know what the server itself consumes. I would assume it consumes BSON, but I'm not 100% sure. But this isn't a string. These are key value pairs. These are clearly all data. If this is something provided by the user instead of the hard-coded string literal hello, if it's something provided by the user, it's just going to be treated as a value that's stored at the key message. It's not going to be interpreted as MongoDB statements to be executed. There are some exceptions to this. The fact that MongoDB doesn't have SQL, doesn't have any injection attacks. There are some exceptions to this. They're rare and they get patched out fairly quickly. Is if a client library doesn't do what it's supposed to do, and the client library that you're using to connect to the server is interpreting what you give it as Mongo code, then you can get into some issues. And you'll see this as you start writing your code. You'll notice that you have to really hard code your MongoDB stuff. Like you can change this to something that will update your values, which we'll see next Wednesday. And you have to hard code that. Like you have to have that in your code. You can't just have it as a string and then just jam it in there. It doesn't work because that would open us up to injection attacks. But sometimes devs write client libraries and they get a little too cute with things. And they think, oh, I'll implement this to interpret that as Mongo statements to help out my users. You know, that'll be a feature that we add. And then they're vulnerable to injection attacks because the attackers say, oh, that's a feature I'm going to exploit. And then it happens. This happened in PHP. The PHP client library for MongoDB had some vulnerabilities like that. They got a little too cute with things and open themselves up to injection attacks. But it's not MongoDB itself. MongoDB itself has not been vulnerable to those. But sometimes there are client libraries that are poorly implemented that connect to MongoDB that are vulnerable to it. So I want to put all that out there just so when you hear injection attack in MongoDB, you're not like, Jesse lied to me. It's in the client code, though. Any case that I've seen, I should say. If we want to get a document, we're going to call find on our collection. Oh, I didn't update these slides. This should be insert one and find one, because why wouldn't they change their method names to not be backward compatible? It frustrates me, but they changed these names to find one and insert one, just to piss me off. They literally were sitting there like, Jesse, we got to get them. The fact that they didn't have find. Just call find one. I don't know. Maybe they have I'm sure they have a good reason, but I don't know. It frustrates me. Anyway, find one is going to get you what you want. So give it a dictionary in Python, and it's going to return anything that matches the dictionary we give it. So in this case, this is going to give me every document in the chat collection where the username is equal to Hartloff. So this would be if I want to get all my chat messages, this is the query I would give it. You can give it multiple key value pairs, and if all of them match, those are the records that are returned. If I want everything, the equivalent of select star in SQL is just find open brace, close brace. That's going to give me everything. So MongoDB, very unstructured. What is the most used in this course is Mongo. Since it was asked, I'll give it right now. But my recommendation will be to use Mongo, which may or may not have been clear from my tone. But I want to clear things up on that and do my comparison here. When would you want to use MySQL over MongoDB? I'm going to answer both of those. And I assume those other questions have been answered. Non-standard reports to add security through obscurity. Boo. There is no security through obscurity. It's not security. But yeah, I can see why somebody would do that. Yeah. So the common port, the standard ports are scanned by bots out there. They're scanned for vulnerabilities. So yeah, I guess you could use a non-standard port to do that. That's not actual security, though. You can't be like, well, I don't want to use prepared statements. I'll just change my port number. Is not, but I can see how that can be an added layer of obscurity. But that's not. Don't do that to be your shield against attackers. Please don't do that out there. Is anybody not running a bot? Anybody who wants to attack you specifically will still find that port. and they'll find your vulnerabilities. Just don't have vulnerabilities. So MongoDB is unstructured. You just throw your documents in there. You can mix formats of documents. If I have one document with keys username and email and another document with keys chat message and timestamp, I can throw those in the same collection. MongoDB doesn't care. When we give it a query, when we say find one and find many, by the way, if you want many of them. I shouldn't have just said find one. Find one and find many. That's going to give you everything that matches those key value pairs that you give it. And if the key doesn't exist, that's just not a match. It's up to you to define the structure and maintain any structure in a MongoDB database. So this can be tough because your structure has to be defined in documentation and just convention and just how you use it, and not in the database itself, because MongoDB won't enforce any structure beyond just organizing things in collections. SQL is structure. That's what the S stands for, as a matter of fact, structured query language. There's tables. They have to be pre-built, predefined. The rows have to match the column names. If you want to add a column, it's a big pain. You have to migrate over to a new table, copy in the data with values for that new one. It gets painful. It's tough, but it's fast, and that's enough. We like speed. We like speed. So here's my hot take on it. MongoDB is great for prototyping, especially when you don't know the structure of your data yet. If you don't even know what the structure is for your data, why do you want a database that's going to enforce your structure that's going to change in a week because you're rapidly prototyping out new stuff? So use MongoDB when you're rapidly prototyping, which is what you're going to do this whole course. You're going to be writing your homework assignment. Your schemas are going to be changing constantly. The way you represent your data in your database will be changing constantly. So if you use MongoDB, in my opinion, it'll just be easier in this course. So if you have no other reason to choose one of these over the other, I would recommend MongoDB just because it's less of a hassle. One, you don't have to worry about getting an auto 0 on a homework for a SQL injection error. Two, you don't have to, I had something in my head for two. The password thing. You don't have to set a username and password. It just by default closes off outside connections, so you don't have to set that up. MySQL will force you to add a username and password, which when we get to Docker Compose next, SQL tends to not play very nice, is the best way I can put it, with the passwords that you set. The way you have to set the password across Docker containers can be problematic. I've had a bug with that it took me hours to do. When MySQL containers are rebuilt, it doesn't reset your passwords. So I changed the password in my environment variable and wherever I was using it, but it never updated in the Docker container. Without getting too far into the details, it was tough. But once you know what your structure is, once you have a more mature app, you're deploying, you're starting to have users, your schemas are settling down, you know what your data looks like, that you know what your columns should be and everything, that's when you pretty much have to use SQL. You shouldn't be using MongoDB at that point. I like MongoDB for prototyping. Once you get to a mature project, switch to MySQL, take advantage of that speed, the efficiency, the structure. It's easier to write bugs in MongoDB if one dev on your team isn't following the structure that you all agreed upon. MySQL will just say, no, you have to use that structure. MySQL is better for large, mature projects. But when you're just testing your apps on localhost, you don't need all that efficiency. You'll have like 5 things sitting in your database. You don't need to save milliseconds. When you have a huge app deployed to thousands, tens of thousands of users, and you're not using SQL, you're really going to see the performance hit from MongoDB. And SQL can do, used properly, SQL is blazingly fast. If you index your tables properly, it's extremely fast, extremely efficient, especially when you have millions of rows in a table. You need SQL. You need that structure. So that's my hot take on it. They each have their place. For this course, for what we're doing, I'd recommend MongoDB. For the real world, you should be using SQL, some form of SQL. I think Postgres is getting more popular than MySQL, I believe, just from kind of anecdotal evidence. But some form of structured SQL-based database. Excuse me. I think I covered all this on the slide. I'll just leave it up there for a second. Yeah, just the security concern alone with SQL. You forget to do prepared statements, which you should never forget to do your prepared statements, but if you forget to do prepared statements with your SQL, and all of a sudden your homework comes back straight zeros, yeah. That enough, being if I was a student in the class, that enough would be enough to scare me into MongoDB. So you are expected to look up the documentation, figure out how to use the databases. In Monday's lecture, Wednesday's lecture. In Wednesday's lecture, I'll give examples, and I'll show some code in MySQL and in MongoDB, and give examples. I might even start that on Monday. I have a day of Docker examples on Monday. I might slip that into that lecture. So I will show some, but the expectation is that you'll be able to find this on your own. It's a 300-level CSE class. I shouldn't have to point out, here's how you update something in MySQL. You should be able to find the documentation, or just W3 Schools. W3 Schools has a way of explaining things pretty simply, I think, as much as it's kind of strange. But it has a MySQL and MongoDB modules. Like, there are ways to learn this stuff. But that said, anything you need to get through this course, I'll still show in lecture. But the expectation is that you would be able to do that even if I didn't cover it in lecture. All right. Any questions so far? I don't think there's any super deep material there. But if there are questions about any of it, let me know. Talk about Docker Compose then. All right. So we're in a situation where I said download and install your database and everything, and then how are we going to do that? How are we going to do that? So more specifically, how are we going to do that and still maintain what we talked about on Wednesday, where we want the same environment in dev and prod? Are we going to go into prod and install, make sure we have the same exact version of MongoDB, go into dev, make sure we have the same exact version? What if we have different operating systems, though? Like, we have the same issues that we had before, except now we have to run two separate applications to run our app, and those applications are going to communicate over a TCP socket. We got two networked applications that are both running to be able to run our single web app. So we have a problem here that we're going to solve with Docker Compose. Docker Compose is going to be Docker, that we learned on Wednesday, but we're going to add a layer on top of that, which is going to create multiple containers, and we're going to run our database in a container. Now, that's what I'll show in lecture today. I do still recommend that you download and install your database of choice locally and use that for testing, so you don't have to spin up Docker every single time you change a line of code and want to test if it's correct or not. So I do still recommend downloading and installing your database locally, but when you go to submit your assignments, we're going to run your Docker Compose. It's going to spin up your database and your app, and then we're going to test using that Docker Compose environment. I should update this. You can install Docker Compose and use Docker Compose like this with the dash, or you can just not use the dash. The latest version of Docker, if you don't have a dash here and you do Docker Compose, that's going to call Docker itself and say, compose this, as opposed to running the Docker Compose program. So these days, Docker itself just kind of absorbed Docker Compose, so they're not two separate programs, which helps out a lot. So if you just delete that dash and replace it with a space, you'll run Docker and then call its compose command. Either way, you're going to need a docker-compose.yaml file, which is going to maintain the construction of both of our containers. So let's take a look at this. This is YAML. If you're not familiar with the format, it's possible this is the first time you've seen it, unless you've done Docker Compose, or what else uses YAML that's popular? I don't know. But YAML is popular for configuration files. It's a similar solution that JSON solves. JSON is the clear winner for any network communications. If we're sending data over a network, it's almost always JSON formatted. It's just the winner of the internet. That's the format that's used. Config files, still YAML seems to be the winner. YAML is very popular with config files. I think a little bit of speculation, but I think this is more human readable. I think that's why we like these for config files, where JSON is more clear for sending over a network. That's a weird way of saying that, but this is more human readable than a JSON string, I think. So or a JSON object. So this is a YAML file. White space does matter, and let's just go through this one line at a time and talk about what all this is. But white space does matter, just like Python. You see a colon and then some stuff. Like this is indented, so it's part of the services block. This is indented, so this is part of the apps block. This is indented, wait host is part of the environment block. So that white space does matter. So this version is going to specify the version of Docker Compose that of Docker Compose file that we're using. Version 3.3 is not the latest. It was just the latest when I made this slide. I'm not going to use any of the features that were introduced after 3.3, so I just leave my YAML, my Docker Compose files as 3.3. If you want to use some fancier features and you want to update this to like 3.6 or whatever the latest one is, knock yourself out. 3.3 will work for you for this course, for what it's worth. Then a list of services. These are going to be all of the Docker containers that are going to be created by this file. So for each Docker container, we're going to specify it as a service, and those are going to be Mongo and app. You need to pay attention to these service names. When Docker Compose runs, it's going to create a network of our containers, and the host name for each container is going to be whatever you call it in this file. So Mongo, where I'm running my database, is going to run on this network within Docker Compose in a container named Mongo, or with a host name of Mongo. My app is going to run with a host name of app. It's very important to know if we're going to connect to these. Our app has to have code that's going to connect to our Mongo database, so the host name has to be Mongo, where normally, and a few slides ago when I showed the connections, I used localhost. That's if your app is running on the same machine as your database. So when you download and install, you would use localhost. With this Docker Compose setup, you would use Mongo instead of localhost there. This is going to be your host name. For Mongo to create this container, we're just going to use an image. We're just going to download an image, the Mongo version 4.2.5. Again, that version might be a little outdated. If you want to use the latest stuff, you can update the version. But I'm going to specify the image, and this is going to be exactly the same as a one-line Docker file that says from Mongo 4.2.5. I'm going to use just vanilla, straight up, whatever I get in that container, whatever default configuration is in there, that's what I'm going to use, and that's it. A one line, that's it. I'm just using their container with no modifications at all. And I don't even need a Docker file for that. My Docker file will be one line. Docker Compose has syntax to be able to start with an image. I'm just going to start with that image and be done with it. For my app, I have to specify all the things that we specified on that run line. So when we did run, -p, the port numbers, the dot, all that stuff is still in here. So build and then dot, this is the directory where it should look for the Docker file for this container that's going to be built. I'm going to put my Docker Compose.yaml file in the same directory as my Docker file. So I'm just going to do build dot, and that's the same as the trailing dot in Docker run when we ran our container. So we just have build dot, look in this directory for a Docker file. If I want to set any environment variables, I just mentioned environment variables for your SQL passwords. This is where you can set them. One place you can set them if you want these environment variables set in your Docker container. Do environment, and then a list of all of the environment variables you want to set. I'm setting a wait host variable to Mongo 27017, which we'll talk about right now. So I'm setting this environment variable, and I'm going to edit my Docker file in a way that's going to consume that variable. It's going to use that variable. So I have a problem here. I have a problem here. I got my database running. I run this Docker Compose file. It's going to spin up both these containers in parallel. I shouldn't say in parallel, but concurrently. It's going to spin up my database, and it's going to spin up my app at roughly the same time. The first thing the database is going to do is all of its initial configuration, its setup and stuff. It takes a while to spin up a database server. It's got a lot of stuff to do. One of the first things my app is going to do is connect to that database. Well, my app, if I'm starting these at the same time, my app's going to say, yo, database, I'm ready to connect. Here's my URL, port, and everything. I'm ready to connect to you. And the database says, I ain't ready. I didn't even fire up my TCP server yet. App crashes, you get an error, nothing works. So what we need is a way for our app to wait for the database to be ready, not just to be running, not for the container to be built and running, but for the database container to be ready to accept TCP connections before it can start. So that's what we're doing here. We're setting up this shortcut. This is the simplest way that I found to do this. If you find a simpler way, let me know. There has been a proposal to add something like this to Docker Compose itself to be able to do this, but last I checked, it wasn't there yet. There is a way some students say, oh, I got the solution. You just add this one line to your Docker file, and it'll wait for the other container to be built, and then it'll run. You just wait for that container. Well, you're waiting for the container to be built, but the container builds and runs, and Docker Compose is like, yep, you're good to go, while the database is still running its startup script. And it's not ready for TCP connections yet. So we need a way to wait until it's ready for TCP connections, and that's what all this stuff is doing for us. So we're grabbing this code from GitHub username UFO Scout. I don't know who they are, but they're my hero. And they made this code publicly available for us, so we're going to download this wait program. We're going to change the mod to make sure we can execute it. And then we're going to call the wait command that we just downloaded. And then after this returns, then we're going to start up our app. This wait command is set up to look for an environment variable. It's going to read an environment variable named wait host, all capital with an underscore. And it's going to take a host. It's going to take host, port number, pairs, and then a list of these. You can wait for multiple hosts, I believe. I have never done that, but I'm pretty sure it supports that. And we're going to wait for Mongo, the Mongo service, to be ready for TCP connections on 27017. So wait is going to keep pinging and saying, hey, you ready for a connection on 27017? And then once Mongo says, oh, yeah, I can connect, do the three-way handshake, it's successful and everything, then wait says, okay, I'm done. And then our app starts up. And then when our app starts up and connects to the database is ready for connections, and we're good to go. And finally, this is the same as our -p, mapping a local port to a port inside the container. Oh, there's one more big point. When you inside a localhost, it's Mongo. But why? This is irritating me. So